Oh, today? No, it's not going to get very warm today. But no, it should be done snowing now. Ryder's driving you, so it should be fine. He's taking the Freightliner, I think, the new coach, the leather seats one, not the cloth seats one of the coaches. Okay, so you get a big bus, a nice bus.
Yeah, but the buses like to break down a lot.
Yeah. All right. So critical numbers help us find minimums and maximums, and that's with Extrema. And he has a video about the extreme value theorem on there, which is basically in between 2 points, you're going to have a minimum point and a maximum point. Okay, unless it's a horizontal line, then every point is a minimum and maximum. But otherwise, any kind of a curve is going to have some sort of a minimum, some sort of a maximum if it's in between 2 points. So critical numbers help us find where that minimum maximum is. So critical numbers are where the first derivative equals 0 or where the first derivative is undefined, given that that undefined point is somewhere different than where the original function is undefined. That's where it gets a little complicated. Okay? But if you know critical numbers are where the first derivative equals 0, that's the main part. Okay? Okay. We good? So let's look at this. Where are our critical numbers on this? So what do? We find the first derivative. Well, I mean, yeah, the first derivative gives us the slope. So let's find the first derivative, which is 3x squared plus 2x plus 1. And we set it equal to 0. Because critical numbers are where the first derivative equals 0. Boom, boom. Got to know that. Okay. So, can we factor this easily? Looks kind of tough to factor, right? So if we can't factor it, we use the quadratic formula. What's a quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. You did not learn that as a song?
No, I was just like, here's the formula.
Oh no, you've got to learn it as a song. I used to make my Algebra 2 kids sing the song in class back when I taught Algebra 2. So, I guess.
So that's
all
what
right.
people talk about then. Because I've heard people talk about that, but I never understood what they meant.
Okay, that was the song. So if we fill it in, negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 3 times 1, all over 2 times 3. So we get 4 minus 12, which is a negative number in here. A negative square root is like fairies and leprechauns. It is imaginary. Okay? So, are there any critical numbers? No. There are no critical numbers because the first derivative cannot ever equal 0. So, there are no critical numbers. All right. We have critical numbers on this one, though. Trust me. What's the first derivative of this bad boy? It's e to the x squared plus 2x times 2x plus 2. Set that bad boy equal to 0. Okay? Don't worry about this part. Worry about this part. Okay? Where is this equal to 0? Well, 2x equals negative 2. X equals negative 1. So negative 1 is a critical number. If we set e to the x squared plus 2x equal to 0, we'd have to ln each side. What's the natural log of 0? Calculator, please. The natural log of 0 is 1?
Oh, I thought e to the... Is e to the 0?
E to the 0 is 1, yes. What's the natural log of 0? Error. It's undefined. You can't do it. So you can't do that, but we can do this part of it. And so our critical number is x equals -1. Okay? This one. Okay, this one tripped me up. It looks easy, but it's not quite so easy. Okay? So on this one, do we have any undefined points going into the problem? -2 is undefined. So we're undefined at x equals -2. Now, find the first derivative. How do we find the first derivative? Oh, come on, people. Quotient rule. So you take the denominator, x plus 2, times the first derivative of the numerator, which is 2x, minus the numerator, x squared minus 3 times the first derivative of the denominator, which is 1, over the denominator squared. So if we do the math on the numerator, we get 2x squared plus 4x minus x squared plus 3, because you got to distribute the negative sign, over x plus 2 quantity squared. So we get x squared plus 4x plus 3. Is that factorable? Yes, it is. X plus 1, x plus 3. If we set it equal to 0, if we multiply both sides by x plus 2 quantity squared, that just disappears, right? So x equals -1 and -3. So those are our two critical numbers. Now, our first derivative is undefined at -2, but if it's also undefined at the same place our original function is, then it's not a critical number. So that's not a critical number. Now, if this was something different than that, then it would be a critical number. Okay? So, you need to know that. Okay, last one. Last example. Okay? How would we do this? How do we find the first derivative? Yep. Or else do the quotient rule. Doesn't matter. Okay. Let's do the quotient rule just, for giggles. X squared minus 4 times the first derivative of the numerator, which is 0, minus the numerator times first derivative of the denominator all over the denominator squared. So that's 0. So you get -2x over x squared minus 4 quantity squared. So that equals 0. If we multiply both sides by that, that disappears. 2x equals 0. So x equals 0 is a critical number. Now, does this have undefined points in it? 2 and -2. Is that the same undefined points as that? Yes. Since they're the same undefined points, it doesn't really matter. So then 0 is our only critical number.